Welcome to www.shipcalculation.com. Today's topic single crane beam calculation. Before you continue, don't forget to subscribe to our YouTube channel, Shape Calculation. Crane beam is a spreadsheet program written in Microsoft Excel for the purpose of the analysis of either S shape or W shape. Means that either you are using this H beam, I beam, or phi. With support beam is analyzes simple span with or without overhand cantilever. Specifically the x-axis and y-axis bending moment as well as any torsion effect are calculated. The actual and allowable stress are determined and the effect of lower planes bending is also addressed by two different approaches. This calculation based on the reference from the ESD or American Institute Society Construction third edition, or you can see from the American Institute Society Construction Steel Design Guide series. Design guide is 7 industrial bidding, or you can find in any other rules like DMP from the lifting rules. If you want to do the manual calculation, normally you need to know the force that we are going to apply for these beams. In this application, Excel sheet, we apply 6 ton or 6,000 kilogram. You can change based on this section that you are going to use. If let's say that here the 6,000 kg, and I can see here the crane girder span between the two spots is the 5 meter. Impact factor we are using here is a 25% from the total force. And then the impact, the safety factor we are using here is a 1.35. You can change to make safe your lifting calculation before you do the testing. You might change to be 2 and maximum is 2.5. The beam that we are using is the size of the width flange is 250 mm. Thickness is 12 mm and then the height is 450 mm. The thickness is 6 mm and then the below flange is the 250 mm and then the thickness is 8 mm. We can change, make it the same here, and then you can see this is the automatic section property of the H-beam will be generated automatically. So when I change to here, let's say 6 mm, and you can see this one automatically change. So you don't need to change anything except the blue text showing to this Excel sheet. And you need to see the result of the load on the crane girder. Normally there's a dead load, live load, and then the design value, moment X, moment Y. This is to check is the check compartments. Check compartments means either this beam is the slender or non-compact. So this beam is the slender, so you need to change the thickness to make it non-compact. Change to, let's say this one is 12, 10. Another one is the 10 also. Okay. 10, and I can see the result still slender. So means is let's say 12, 12 now become is non-compact. You didn't see any the red warning is here. Check compartments. Okay, and you need to check the bending stress also. Okay, the bending stress subject to moment X for the compression plunge, and moment Y is compression on the plunge. And this one is a safe because is below 2 ton per centimeters square. We get 1.23. You need to check the shear stress also, and becomes safe 0.35. Okay, and then you can get a 0.56. So the flexion also is set. So whatever, if you can see this one is all set, but when I change to become smaller the beam, let's say I put here is a 300, and you can see the result is unsafe. So this is the automatically will be generate either this beam that we are using is the safe or not. And don't take this any dimension if still showing the red warning here or unsafe. You need to change the beam to make it pass all the formula, means that this calculation are able to use, and you can check any rules against with this. Once the beam is the same, we need to see this vertical support. Okay, this vertical, because the girder beam just now we already double check and set if we are using this H beam 450 mm, and then the thickness is 6 and the planche is 250, but the thickness is 12 mm. Okay, now we need to check the single crane beam support. To check this single crane beam support, you need to know that the geometry data that we are going to use. Okay, the vertical load is the same, and then from this we are using 2 support times 1.5. After that, we need to know also wind load acting on this the side support. uh, on the girder beam and side support. After you know everything, the total depth, the wind load, and you need to determine the material property. The material property here we are using is the same. The modulus of elasticity is the 2000 Newton per millimeter square. The yield stress is 355, or same like the EH36. The ACTM, and then this is the permissible wear stress. The section property that we are using here is a different from the girder beam. Okay, so please take note, only the blue text that you need to focus to change, the others you don't need to change. Okay, otherwise we will be affected with the formula inside the Excel sheet. Take note with this. This is just to make sure, to make easy for you, so you don't need to focus on the formula, but you have to focus on the geometry, and then the force that we are going to apply to the discount calculation. When the this is also the same with the girder. If you are the girder beam above, when you change the breadth or the thickness, and then will become automatically will show you whether this the combined stress, actual shear stress, shape or not. Can see here shape. But when I change to make it small the thickness, let's say a here also a. This is the automatic generate all the section modulus then moment inertia, and you can see here unshaped. See this one unshaped. Okay, so means that you need to change the thickness. This is still unshaped. So how to change with this? You need to play and make sure that this is the correct size material. It's available on the market. And you can see here same. Okay, so I think that's all the calculation Excel sheet of this the cramping girder calculation. If you meet the same with your design, and you can choose this the Excel spreadsheet calculation. Don't forget to subscribe our YouTube channel Shipcalculation. Thank you very much for watching, and see you for the next topic of the calculation. Thank you.